Aircraft wings do a lot more than just provide lift. Hidden within the design are clever features called auxiliary lift devices, special control surfaces that help an aircraft take off, land safely, and even reduce drag. Today, we'll explore the fascinating world of flaps, slats, spoilers, winglets, and more. Before we continue, I've got something to help you level up your airframe knowledge. We have created a feasible and printable airframe workbook, packed with multiple study formats and answer keys. You can complete it right on your device or print it out for hands-on study. Get your instant PDF download now from our Gumroad store or Patreon page. Links in the description. Study smarter, anywhere, anytime. All right, let's get back to our topic. Aircraft wings aren't just fixed surfaces. They're equipped with a range of auxiliary devices designed to fine-tune performance. These devices fall into two main groups: lift-augmenting devices, which help the aircraft generate more lift when needed, and lift-decreasing devices, which reduce lift or increase drag for better control. Let's break them down one by one. Lift-augmenting devices are critical for safe takeoff, landing, and low-speed maneuvering. By changing the wing's shape or surface area, they help the aircraft generate more lift and maintain control at airspeeds that would normally be unsafe. The most common lift-augmenting surfaces are the flaps, located along the trailing edge of the wing. When extended, flaps increase both the camber and the area of the wing, producing greater lift. This allows an aircraft to lift off at a lower speed during takeoff and to slow down more effectively during landing. Different aircraft employ different flap designs. Some flaps are fully retractable, blending seamlessly into the wing's contour for clean aerodynamics at high speed. Others are simpler, extending downward from the lower wing skin to add drag and help slow the aircraft during approach. On the leading edge of the wing, we find slats. These movable control surfaces retract to form a smooth continuation of the wing's shape. When extended forward, however, they create a slot between the slat and the wing's leading edge. This slot smooths airflow at high angles of attack, delaying stall and allowing the wing to generate lift even at low air speeds, enabling the aircraft to remain controllable below its normal landing speed. Not all aircraft use movable slats. Some are equipped with permanent slots built directly into the leading edge. These openings provide the same benefit: improved airflow at low speeds, though they remain fixed and cannot be retracted for high-speed flight. Once the aircraft accelerates to cruising speed, both trailing edge flaps and leading edge slats retract back into the wing, restoring a clean aerodynamic profile that minimizes drag and maximizes efficiency. While some devices are designed to increase lift, others are used to reduce it. These are known as lift-decreasing devices, and the most common of these are spoilers, often referred to as speed brakes. In many aircraft, spoilers come in two forms: ground spoilers and flight spoilers. Ground spoilers are deployed only after touchdown. By disrupting airflow over the wings, they rapidly dump lift, forcing the aircraft's weight fully onto the landing gear. This greatly improves braking efficiency on the runway. Flight spoilers, on the other hand, can be extended in the air. They serve multiple purposes. Most notably, they assist with lateral control. For example, when an aileron on one wing is raised, the spoiler on that same wing may also extend. This increases drag on that side, helping the aircraft roll more effectively. When used as speed brakes, spoiler panels on both wings extend upward simultaneously, increasing drag and reducing lift to slow the aircraft during descent. Some aircraft employ advanced spoiler systems, where the spoiler panel on the side of the rising aileron deflects more than the opposite side, combining lateral control with speed reduction. In specialized designs, spoilers or air brakes can also be mounted on the fuselage or near the tail, as seen on aircraft like the Panavia Tornado. One of the most recognizable additions to modern aircraft wings is the winglet. These are small, near-vertical extensions at the tips of the wings. Their main purpose is to reduce aerodynamic drag caused by wingtip vortices, the swirling air patterns that form as the airplane moves through the sky. By weakening these vortices, winglets cut down on induced drag, which in turn improves the aircraft's overall efficiency. The result is lower fuel consumption, extended range, and in many cases, smoother handling during flight. Another unique design feature found in certain aircraft is the canard wing. In this configuration, a small wing or horizontal airfoil is placed in front of the main wings, rather than behind them, as in a conventional tailplane layout. The canard itself can take several forms. It may be a fixed surface, a movable wing, or even be fitted with elevators to provide active control. Regardless of the type, its purpose is to contribute to the overall lift of the aircraft while also improving stability and handling in specific flight conditions. This design stands out because, unlike traditional aircraft where the tailplane usually balances or counters the lift of the main wings, the canard plays a direct role in supporting the aircraft's weight. Another aerodynamic feature designed to improve performance is the wing fence. These are flat, vertical plates mounted on the upper surface of the wing. Their main role is to block or redirect the spanwise airflow, the movement of air that travels outward along the wing toward the tip. By controlling this airflow, wing fences help prevent the entire wing from stalling at once, especially during high angles of attack. This makes them particularly useful on swept-wing aircraft, where spanwise airflow is more pronounced. The result is better low-speed handling and improved stall characteristics, giving pilots greater control and safety when operating near the limits of the aircraft's performance. From flaps and slats that boost lift, to spoilers and speed brakes that keep it under control, and special features like winglets, canards, and wing fences, every part of an aircraft's wing is designed with purpose. These innovations not only make flight safer, but also more efficient and more capable than ever before. Thanks for watching.